Alright, Exam 1 review. So the purpose of these videos is maybe you want to see, instead of just looking at the solution worked out, you want to see it worked out and explained in real time. So that's going to be the goal of these. And we're going to start with problem number 1 here. Determine whether the following functions are one-to-one on the given domain. So the way we do this is we can draw the picture. This is going to be the most convincing way to do this for you guys on the exam, is draw a picture of the function and note if it satisfies the horizontal line test or not. It's actually pretty easy to say something's not one-to-one if you can just find 2 points where it's equal. But generally I would draw the picture. So let's go ahead and do that. Oh no, okay. So number 1, what are we doing? Actually, I like this better. We want to see which of the functions are one-to-one on the domains. So first we have the f of x equals x, the identity function, and the domain is all real numbers. So from minus infinity to infinity. Right, let me just make sure. Yep. So now we want to see, is this function one-to-one? So let's just draw it. So what does this function look like? Looks like a straight line, like that. And so just by taking a look, we say, okay, this is definitely one-to-one. If I draw any horizontal line, then it's only going to ever intersect at one point. So therefore, the function is one-to-one. F of x passes the horizontal line test. Horizontal line test, comma, and is therefore one-to-one. Alright, not bad. So the next one is to show you, okay, well, not everything's one-to-one. So let's try B. G of z is equal to z squared on minus infinity to infinity. Alright, so let's take a look. What does this function look like? Well, we know what the parabola looks like. And actually, it's only ever positive. So does this pass the horizontal line test? No, it fails it pretty miserably. We would have to go out of our way to pick a line that intersects the graph and doesn't intersect it at 2 points. So g of z does not pass. I'm going to abbreviate it, horizontal line test. So is not one-to-one. Alright, another way you can do a problem like this, if you know it's not one-to-one, is you can say, you can pick two numbers where they have the same value. So g of minus 1 is equal to minus 1 squared is equal to 1, which is equal to 1 squared, which is equal to g of 1. So what's the purpose of this? Well, it tells me g of minus 1 equals g of 1. Minus 1 and 1 are two different numbers, but when you put them into g, you get the same number. So therefore, that's another reason the function can't be one-to-one. So this is reason 1. This is reason 2. Either one is perfectly fine on its own. You don't need both. But that's how that works. Alright, next h of r is equal to sine of r on minus pi over 2 to positive pi over 2. And so we're going to draw what that looks like now. So let's see. 1, 2, 3, 4. Let's make this a little longer. So minus pi over 2 to pi over 2, the sine function is going to look something like this, right? Not the best picture, but roughly like that. So is this function 1 to 1? Again, draw any horizontal line you want. And at most, it can only intersect at one place. So sine of r is 1 to 1 on the given domain. So this is where the idea of restricting the domain is super important. Because if I just gave you the sine function on the reals, then that wouldn't be 1 to 1. But because I've restricted it enough, I can say. And this is, remember, how we were able to define sine inverse is by putting sine on this interval. And then d j of x is equal to x squared on open intervals 0 to infinity. So we're going to have the same idea coming through. Now we can draw it. X squared. What's the big thing that changed? Now we're only allowed to plug in positive numbers, where before we could plug in anything we wanted. So if I plug this one in, there's an open circle here at 0. And now it looks like that. So is this 1 to 1? Now it's good, right? Because now if I draw a line, only one thing can be the square root of x, and it has to be positive. So getting rid of those numbers helped me a lot. So j of x is 1 to 1. Okay. So good there. Keep going. E cosine of x on minus pi to pi. And what's the name of that one? K of x equals k of x. So let's draw out what that's going to look like. Here we go. Start at 1. At pi over 2 we're at 0. And then at pi we bottom out at minus 1. And then similarly on the other side. So is this 1 to 1? Pretty painfully not. So k of x is not 1 to 1 because it fails the horizontal line test. Is not 1 to 1. And just like in the other one where it wasn't 1 to 1, we could also say cosine of, say, minus pi over 2 equals cosine of pi over 2 equals 0. And both of those would also be an issue. Alright, so next is f. So L of x, which is given to be e to the x plus 5. So let's draw that one out. We know that it's e to the x, so it's always positive, and we're adding 5, that's positive, so we really don't hit the negative axis. And you should be comfy with the idea that the exponential function looks somewhat like that, and then we've moved it up by 5. So is this 1 to 1? Yes. And actually, I didn't even give you the domain, but it could be any domain. Yeah, so minus infinity to infinity, say. So good, this function is 1 to 1. L of x is 1 to 1. And that's how you would do one like this. Basically, we draw the picture, see if it passes or fails the horizontal line test, and that'll tell you if the function is 1 to 1 or not.